All right, so 2-3 kind of piggybacks off of 2-2. We're going to talk about biconditionals. So again, hopefully you know what the prefix bi means, right? Bi means two. So obviously this thing we're going to talk about involves two conditionals. Now those two conditionals are going to be a conditional and a converse. And we're going to talk about that on the next slide here. Oh, sorry about that. There we go. Okay, so a biconditional. So a biconditional is a single true statement that combines a true conditional and its true converse. So again, when we say true, they have to always be true. Always true. So it can't be true. Sometimes they're like, oh yeah, there's one instance where it's true. No. If you find one instance when it's false, then that statement is false, right? So it has to always be true. And again, the key words for biconditional are if and only if. So we get rid of the if and then idea, and we put the if and only if in between our hypothesis and conclusion. Okay. So again, here's your example. A point is a midpoint if and only if it divides a segment into two congruent segments. So that's the definition of a midpoint written as a biconditional. Now, what I'm going to do is I'm going to break that into its true conditional and its true converse. So let's talk about the conditional, C-O-N-D for conditional. So if I write this as a conditional in the order that it's written, it would say if a point is a midpoint, then it divides a segment into two congruent segments. I hope you don't mind the shorthand. Again, it's just your notes. So that is true, right? Because if a point's a midpoint, then it divides a segment into two congruent segments. A midpoint bisects a segment, splits into two congruent parts. So now what about the converse, C-O-N-V for converse? Well, let's take this conditional and write it backwards, right? Reverse it. If, now again, I'm not going to start with it. If a point divides a segment into two congruent segments, then it is a midpoint. That is also true. That is the definition of a midpoint as well. If a point divides a segment into two congruent segments, then that point is a midpoint. So because these are both always true, always true, always true, that's why we can write the biconditional. Sometimes the conditional and converse aren't always true. And then you could not write the biconditional. You would just explain why one of them is not true. All right, so I believe I have two examples to show you along with this video. Okay, so problem one, it says a conditional statement and its converse are written below. The conditional, if 3 points are on the same line, then they are collinear. Converse, if 3 points are collinear, then they are on the same line. Determine if the conditional and converse are true or false. If both statements are true, write a biconditional using the order of the conditional statements. If one statement is false, identify the statement and explain why. All right, so these two statements are true. Right? Being on the same line and collinear, that's the definition. And it doesn't matter which way I say it, that is true. Both statements are true. So because both statements are true, I will write this biconditional. I'm going to follow the order of the conditional statement. Now I'm going to take off the word if. So I'm going to say 3 points are on the same line. And now here comes the magic words if and only if. Don't write the word then. They are collinear. There we go. And again, the reason I can write this biconditional is because this is true forwards and backwards, two ways. Okay, next problem here. Same kind of directions. So the conditional, if two angles form a right angle, then they are complementary. Converse, if two angles are complementary, then they form a right angle. So if we look at the conditional, if two angles form a right angle, right, a right angle is 90 degrees. What does it mean to be complementary? It means to add to 90. The conditional is true. Let's look at the converse. If two angles are complementary, then they form a right angle. I don't think this is always true. Let me show you an example, right? So what if your two angles are not even touching? What if they're non-adjacent? What if one angle is here? Let's call that angle A. Let's say that's 30 degrees. And what if the other angle's over here? That's bad drawing. Sorry. Let's make it a little bit more believable. That looked like a right angle itself. Um, how about this? Right? Let's call this angle B, and let's say that's 60 degrees. So right now, do these two angles form a right angle? No. If I slid them together, would they? Yes. But they're not together. They're not adjacent. They're apart. But they are complementary, right? Yeah, 30 plus 60 is 90. So these two angles are complementary, but they don't form a right angle. This proves this converse is false. So somehow, some way, so it says if one statement is false, identify the statement and explain why. So now I have to explain this in words, right? So the converse is false. Two non-adjacent angles can have angle measures that sum to 90 degrees. Okay. I did not leave you an opportunity to draw a picture. Pictures are great. We call them counterexamples as well, explanations. But again, it's important to talk about words. So that is a non-adjacent picture I drew. Two angles that are not sharing a side. Great. Good luck with the homework.